distance versus tool exploration. What did you notice slash wonder? Play with this.
Okay, wonder how it works. Oh, cool.
And we're going to talk to your audience. Tell them what you're doing.
Hmm. Maybe that too. What does this button do? Oh, I see. The starting point. No, the end point too. Stretch out. Oh, I see. So that means 28 and 69, all those 3 blocks away. I get it. Maybe 2 blocks away. I'm trying not to get it. Just to... You can? Hmm.
My favorite tools are the next 3 that you haven't even looked at yet. Those are my favorite.
Oh, I see. It shows you like the prime numbers, like from prime climb. And this one doesn't show you the answer. And this one doesn't just tell you anything. So I'd have to basically write in it. Oh, not text. Oh, go away. No. I have no idea what this is for.
Alright, so zoom it out so you don't have decimals anymore.
How?
You grab the number 30 and you bring it closer to the number 29. There you go. Well, that's really zoomed out. Zoom in a little more. There you go. That's pretty great. Alrighty.
Let's stretch you all the way up there.
If you just click it, there's a little X. But
Well.
maybe it's up really high.
Is that just gonna be stuck there for a while? What's the X?
Do you want to delete everything off?
Yeah.
Just hit refresh on the screen then.
Okay.
Alright. Put a prime climb chip on the number 20.
This type?
Yep. Well. Alright. What do you notice about the 3 colors?
How about both orange and those 1 5?
So what does that mean to get to 20?
Maybe. Oh, wait. It's a 2 and a. Oh, those 2s.
Grace is now in your video.
So 5 times 2, then 10 times 2.
Yeah.
Oh.
So let's not put a chip on 10 yet. Do you think you know the colors that are going to be in number 10?
5. 2 blues.
2 blues. All right, go ahead and put it over there.
That's what I think. Am I right? Oh, it's a 5 and a 2.
Why was it a 5 and a 2?
Because it's 5 times 2. I wasn't thinking about that. So that means.
So where does the 2 blues actually go?
That means it's on 25.
Haha, nice. All right, I think you got the hang of this.
Yeah.
So you can head down to this slide here.
Okay.
Do you want to put in what you noticed and wondered? Go ahead and move your down if you do.
Oh. Right, Mom.
Nice.
I had trouble spelling multiplication, so I just put in the time symbol.
Perfect. All right, check out slide 15. It's going to give you one challenge after another as we go through them.
What kind of numbers are most likely to have a red prime? Numbers which have prime numbers in the multiplication sentence. So let me just quickly find a prime number. Oh, I feel like 19 is. 19. Yep, 19 is a prime number. So, if I get this shapes, let's see. I didn't really like that cold thing it is. Sort of like that.
It's a little tricky to make, but I use two circles, an outer circle and an inner circle.
Yeah, but how do you get it to turn like that?
It required a lot of cropping.
Oh.
It was kind of a pain in the butt.
I'll just sort of draw the color. I'll just write it. Alright, so right. Because that's a prime number. Then if you do that, it can equal that.
So what colors would be on 38?
Let's see. Let's look back over here. A red and an orange.
A red and an orange. All right, go ahead and grab that chip and bring it down to 38.
40. 6, 7, 8.
Spot on, dude. All right, I think you're ready for the next slide.
Okay. Alright, create a number greater than 100 that has no red primes. Does it have to be in prime climb?
Has to be on that app.
Okay, gotta scroll away. It's 100.
So move the little magnifying glass to 100. And what that does is it'll always keep 100 on your page. It won't run off the edge.
I take one of you. Oh, so it can't have a prime. But 101, 102. You can make that. But, oh, that's a prime. That's a prime number itself. Wait. Oh, come on. Okay, so a purple, a green, and a blue. So,
Do you know how to take a screenshot? Hold down Windows and Shift at the same time, and then tap the letter S for screenshot. I think you also hit caps lock. Just use your other finger. Hold on the window. Hold down Shift. Now other finger. Oh yeah, sure. You can do.
S.
All right. Now highlight the area you want to snip. We'll also get the number line so we know what number it is. There you go.
Can I move this?
Yeah, you just have to do Apple or Windows Shift S each time.
Okay.
Oh, there you go. Lovely. And I click over here.
Yeah.
And do paste.
Huh?
Right there. Just hit delete. All right. Do you know how to paste? Control V.
Control V?
Yeah. V for paste. I have no idea why it's that. Isn't that cool that you can get a part of that screen and put it there?
Yeah. So now, just give me a sec. That point line pointing to each one of these. Control D. Alright, Mom, I made it point to each one of them.
Neat. Are you ready for the next challenge?
Sure.
All right, go to slide 7.
What could A equal? How many possibilities are there? Like in all of numbers?
It's 1/3 red, 1/3 green, 1/3 orange.
Well, doesn't it have to be one? There could only one exist. Because not all three, none could be the same, right?
Well, all oranges are the same, right?
Yeah, they're all two.
What are all greens?
I get it because red's all primes. There could be tons. How could I figure that out? The only method I know, but it would take a long time for my method to work. Mom, the magnifying glass doesn't work.
The magnifying glass just says whatever number the magnifying glass is on will stay on your screen.
Really? Like 100?
I know. It'll stay on your screen when you zoom in or out.
Really? Do you know any way that I could do this?
Sure, I know lots of ways, but I'm curious about your way.
The only way I could think of it is to just find each one, count them one by one. I don't know any other strategies.
Start with that. Oftentimes, mathematicians start by just checking everything until they notice a
Yellow,
pattern.
red, and green. Yellow, red, and green. Yellow, red, yeah. Yellow, red, and green. Yellow. Oh, it needs to be a prime. Yellow, red, and green. Is there a search thing on this? This is gonna take forever. I haven't even found the first possible answer.
So let me give you one hint. What's the smallest prime number that uses red?
7.
7's purple.
Oh yeah. No, I saw. I just can't remember what it was. I feel like it was like 16. No. Yeah, 17.
There's one that's smaller.
Yeah, I thought so. 14.
And there's even one that's smaller.
9, 7, 6, 5, 4, 3, 4, 2.
Oh, you found an Easter egg.
Wait. Oh. Ooh. No. That's a cool Easter egg though, why?
You found it. There's other Easter eggs in this. There's fun, cool little things.
Really? Well.
You just have to play with it to find out. So keep finding it. It was below 13.
11.
Yep. Now try to figure it out now that you know that red could be 11.
So 11 times 2 is 22. And then 22 times 3 is 66.
How could you check?
If it was correct, it should. I'm just gonna head over to 66. Oh, oop. Let me just go check real quick. 60. Yes!
Cool. So write it down on your paper.
66.
All right. The question is, how many possibilities are there? Can you find another chip?
In all of numbers? Because that would be infinite.
Tell me why.
Because I would just keep getting more and more and more of those numbers. It would go on for infinity. This video would go on for forever. Plus, new numbers are constantly being found.
So.
Well, not constantly. Every like year or two, I guess.
Could you find another number that has those three?
Sure. Do you mind if I get something up on this? Put like something else up?
Yeah, go ahead.
Okay. With that like long bar on the bottom, which you search on.
Keep going over.
Oh. Yeah. Calculator. Let me bring in the calculator to help me out. Okay. This one. Where should I put this?
Right on the side is fine. You can always move it when
Put them there. Okay. Not scientific. Just a standard one. Oh, the mouse is freaking out a lot. Just blinking all over the place. That's weird. So if I want one of those, I need to do 14. 14 times. Where's good? 14 times 2 times 3 equals 78. So the next one is 78. And yep, 78. And I can just keep on doing this with the calculator as long as I know what the next prime number is. So, like, what was that chart with the prime number? Do you have like a chart of that? That would be really useful because I could do all of them like up to maybe like 101.
So if somebody wasn't sure how to do this, could you explain the rule for figuring out anyone?
Yeah, and just get a text box in. Control Shift. No. Control Shift up the side of these a bit. Okay, so prime times 2 times 3 space equals dot. No, I'll just do a mystery. Here it is. Equals.
And do you remember what they wanted this to be? In algebra, we would use that letter. We would say equals A.
Okay. So equals A. Shift A.
I think you have caps lock
Also, if you hit shift, it goes lowercase.
Mhm.
Let me just turn off caps lock. Alright.
Very impressive rule. You wanna go to the next challenge? I think there's another slide.
Definitely. Yeah, there's much more slides. Can you create a chip with 20 parts of it? I might be able to, but that means you'll have to have 20 numbers in the equation. Wait.
20 numbers in the equation.
You have to have like 20 numbers in the equation. I mean, look. Look. Like, we have to go way.
Well, look
Up.
at 50,000. What's that one? That's just got 3 parts.
Yeah. Wait, that's not 50,000. That's slightly off. I have to find exact. Mom, do you know if there's a way to type in 50,000 in
You can
this?
zoom in. Put the magnifying on it though, so it doesn't disappear.
Um, 7. Why can't I zoom in anymore? Oh, there are. Whoa!
How many
1,
pieces
2,
are there?
3, 4, 5, 6, 7, 8, 9. Not even 10. Where am I gonna find the 20? It's not on here.
Can you write that equation of what that number would be?
Okay,
Or you could say it.
I'll do it. Okay, so 5 times 5 times 5. 1, 2, 3, 4, 5 times. Five times 2 times 2 times 2 times 2 equals A. No, not plus. What cap lock's back on? Oh wait, no. Equals A.
And what is A? Is A any number right now, or is it a specific?
Oh, I'm thinking 5 0 0 0 0. That is incredibly hard to see. Give me a sec. Control Shift size up. That is much better. There, that is so much easier to see.
Neat. So do you think you could come up with one that has 20 parts?
Don't think so.
How come?
I mean, it's not going to be able to fit on this. I mean, not that I know of. Look, the farthest it can really get is. No, wait, it keeps going. How big does this go? Still go? Oh, sorry, I have matched the end actually. Now, how do I zoom in here?
You drag the number. You see the digits? Yeah.
Well, don't go down to those types. That's just a simple number. Stop giving me like point something. No. Okay, so what is this? Not actually that as much as I expected.
What did you expect?
I was expecting it to have tons of them. But I guess that was fun.
So the programmer kind of ran out of space with these numbers, didn't they? They don't really go on to infinity.
Oh, now the person this. Yeah. So it does have a stopping point.
So if this could go forever, can you make the equation for what that number would be if
Give me a
something
sec.
occurred? Of course.
Mom, I don't actually know the answer to it, so how am I supposed to do it?
Hmm.
Mom, just one more number.
How many are there?
Only 10.
Only 10. Can you write that equation down? Everyone's there.
This is kind of holding my head a bit, all of this math. Okay, so 5 times 5 times 5 times 5. Let's say 4, then times 3 twice, times 3 times
Equals what?
equals 90000.
So cool. So you got up to 10 pieces, right?
Yeah.
High five. If you want one more, there's one more slide.
Really, of these it?
Yeah, these are just copied of the same thing.
Oh, this is a slide.
Yes, yeah, they just because people might have like multiple answers.
So you want me to try to find this set of numbers?
Mm-hmm.
So a blue. I'm gonna need a main number because I know those are blue times the primes. Hmm. Give me a sec. Times 2. A fourth. I'm just gonna refresh this out. It's so easier. Did that say not secure?
Yes, it does.
Why?
Whenever you see that, just don't put your personal information on it.
So I need a blue and a red. Blue and a red. Aha. Blue and a red. But what's next? A purple. Oh, so this is the next because it's not a purple. See?
Oh.
It's not 55. Blue. What could this be? What could this be? Let me head back over to 11. Yeah, so 11. And is there, no, I guess not. Hmm. Yeah, because that'd be, huh. I actually don't know how I could find that.
only had to find, whoops, there we go. What if you only had to find these two? Ignore him. Could you find those two?
I don't know. This is just too hard for me.
You can take a break if you want. This was just a challenge. You don't have to do it.
Yeah, because Mom, this is pretty hard. I just want a break.
Sure, take a break. Tell your viewers bye-bye. Thanks for watching.
Bye. Thanks for watching.